Okay, I've got week 2. Our topic has been on machine learning, and I've got 3 prompts to go over. First is, what are these steps in machine learning? And I've seen a lot of diagrams that give much more detailed steps, sometimes 8 or 9. But what we're working with right now for our simple learning version, which I think still maps onto more complicated schemes, is a sort of 4-step plan. And the first thing you do is you collect your data, and then you fit your data, you make a prediction, and you evaluate it. So we have those 4 steps. And in the beginning, when you are setting up your data, you have to come up with sort of what is your trajectory, like what target are you going for? What is the point of having a machine learning model? So based on your data, what kind of predictions can you get out of it? So usually this first step, you examine your data and clean it up and select the columns that you're going to have in your data frame that you feed to the model. And you want to split that up so you can train it on part of the data, and then you'll have some of it left over for testing. And then the second step, fitting, is when you make sure that the data is going to be useful to you in training. And so that involves like identifying which features you're going to use and making sure you don't have empty fields, making sure that you don't have too much or too little. Because if you have too much or too little, you might get poor results due to overfitting or underfitting the model. And so once you have your data set, you train your model. And once you have trained it, you check if your prediction is meaningful and if the model is able to make the prediction that you were expecting, and or a meaningful prediction depending on well, I think in this case it's supervised learning, so you would have expectations. And once you have done the training component, you then come back with testing. And we've talked a bit about overfitting and underfitting, and I'm bringing it up now because of the testing component where you evaluate your model. If you give your model too much data, you run into an overfitting problem where, because of the amount of data, the model does well in the training component, but once you go to testing, it doesn't do as well with its predictions. There's a ton of extra noise. And so what you do for this is you have to go back and rework your data, either cleaning it up and making it better or removing a bunch. So like maybe you will remove layers from the model, like training layers, or you might end up removing features like columns, like if you have just too many things going on. And with underfitting, underfitting your model does poorly in both the training and testing phases. And usually it's because the data is too sparse, so you don't end up having successful predictions. And I feel like that's a bit easier to solve as long as you can obtain more data. Just adding more so that your model has more to work with. And then hopefully you'll get through both the training and the testing parts. In terms of, I haven't yet created a model and done these steps, so I don't really have an example of when I have gone through this process yet. So I'll have to probably follow up on that question once I've finished up our project. And then we had an additional question. What is feature engineering? Sorry, I went out of order, so I just did 1 and 3, and this is our second. And I think feature engineering, I did sort of touch on. It's towards the beginning of the machine learning lifecycle, where a feature, the way I like to think about it, is it's basically just a column. So if you have the most like simple version of data would be like a spreadsheet or a CSV file. And this is sort of towards the beginning of the process when you are designing your plan and determining what data would give you accurate or interesting predictions. Feature engineering is where you take the specific parts of the raw data that you have and make sure it's something that you can put in a data frame, make sure that it's data that will be successful, like with no empty fields and no anomalies, not too much repetition, nothing that is like too specific or too like no outliers, for instance. So feature engineering is just making sure that the components that you want the model to predict on, usually a column category, are going to be similar enough and different enough to give the nodes of your network something to work with. Yeah, I'm trying to think. I honestly can't think of a time where I've had overfitting or underfitting problems since I've only done the one. So, but if you, BC, if you want to kick it back to me with like a different version of the question or get back to you later when I do have an example, that's totally fine. I just didn't want to put off this video any longer. So anyway, see you soon.